Hey everyone, today we're going to be going over the midterm review part A.
Combine any like terms in the expression. If there are no like terms, rewrite that expression. So we have a 10h and a 2h. So we just add the ones with the same base. So we have 2 h's here. So 10 plus 2 is 12. So our answer is 12h. Alright. And then similarly with this one, all three of these bases here are f to the third power, which means we can add the 8, the 5, and the 2 together to come out to 15, and then we just keep the base exactly the same, f to the cubed. We don't want to add that exponent together. Our next one, we're subtracting. We're just going to combine like terms. We're not going to solve for y or anything like that. So with this one, you have to be careful because there's a parentheses here. So what you'll have to do is distribute that negative into both of these. So we'll end up with y plus 7 minus 7y plus 7 because we have a negative and a negative, and that'll be a plus. So then from here, we'll combine our like terms. So we have a y here and a negative 7y. So that will combine into a negative 6y. And then we have a plus 7 and another plus 7. So that will be 14. Well, that is that answer. And then another one similarly where we have two things in parentheses that we need to add together. Except this time, when you have a plus, nothing actually cancels, so we're distributing this positive sign into both of these, but a positive and a negative are still a negative. So we end up with 7y plus 8 plus 5y, minus 3. And then combine like terms, so 7y plus 5y should be a 12y. 8 minus a 3 should be a plus 5. So that is what you put as your answer. All right, moving on to problem number 5. We're going to be solving for b this time instead of just combining like terms like before. So we will still have to combine our like terms in order to solve for b. So we have a negative b, a 10b, and a 2b that are all like terms. And then on this side, we've got a 17 and then equals 6. So we're going to combine like terms on both sides of this equation until we're not able to anymore. So 11 b will be the combination of negative b, 10b, and 2b. So I'm just going to write that down right here. So we have 11b. This 17 can't combine with anything else on this side of the equal sign. And the 6 is by itself on the other side. So we're just going to bring those terms down with our new 11b. And then we will subtract 17 from both sides since our goal is to get b all by itself. And I'm just going to keep moving on with this problem over here so that we don't go into the next one. So this will be 11b is equal to 6 minus 17, which is negative 11. So would you look at that? If we divide by 11 on both sides, it looks like our b will be equal to negative 1. And that is the answer to this problem. As a reminder, why we decided to divide by 11 on both sides is because right here there is an 11 next to this b, which is the same thing as saying 11 times b, and whenever we need to isolate something, we have to do the opposite of what's happening to it currently. So right now, 11 times b, how do we get rid of it? We have to divide by 11 instead of multiplying. So that is problem number 5. Let's get down to 6. 6 again, we're solving for d this time. But same thing where we combine like terms on either side. So we have a negative 8d plus 11d, which would be a 3d equals 9. To get d by itself, we're going to divide by 3. So we'll end up with a D is equal to 3. 7, we start to jump into inequalities, but we still solve it in the same way. There's just a few rules added with inequalities that we just have to keep an eye out for. So let us do minus 58 from both sides so we can get G by itself. All right, and then this is going to work out to be 17 is less than G. So, just a word of advice. If there are multiple choice options, or just in general, typically the way that you want to write a problem is you want our variable to be on the left side of the equation. Right now, it is on the right side. Oh, this is an inequality, but so how this problem is going to look if we were to write it in the proper format is it's going to look like G is greater than 17. So notice how our inequality sign used to be a less than, but now it is a greater than. That doesn't mean we changed the problem. That just means we changed how it was written. So these still say the same thing effectively. 17 has to be less than G, which is also the same thing as saying G has to be greater than 17. So just know that if there are a bunch of options, all of the variables are going to be on the left side, and you'll want to pay attention to what side the, say, let's call this the open mouth is facing. So right now we see the open mouth is facing towards the G, and down here the open mouth is still facing towards the G. So that is going to be the correct option. All right, so going down to number 8, solve for R again. I'm just going to rewrite this bigger here. So R divided by 12 is going to be greater than negative 3. Now, typically, whenever we move things to another side, we end up with division. But what happens when something is already being divided? So we have R divided by 12. This time, we are going to multiply both sides by 12. I'm going to write that here in a different color so that we don't mix that up with the original problem. Because R divided by 12, in order to get R all by itself, we need to do the opposite. Right now it's being divided by 12, so we have to multiply by 12. But you can't forget to do that to the other side. So these 12s will actually cancel out, and we will end up getting R is greater than negative 3 times 12, which is a negative 36. And then moving right along to problem number 9, 15 minus a is less than or equal to a negative 36. So let's subtract 15 from both sides, and we'll have a negative a is less than or equal to, that should be a negative 51. All right. And as you can see, we have a negative sign next to our a here. That is not something that we want to leave there, because when we're solving for a, it's just a. We're not solving for negative a. So in order to get rid of that, we can either divide or multiply by a negative 1. Usually I just like to call it division. But when that happens, there's a special rule with inequalities that makes it so that we have to flip our sign face the opposite way. So right now it looks like this, but after we divide by negative 1, our answer is actually going to be a is greater than or equal to 51. So that sign has to flip. So be super careful when dividing by a negative. All right, let's scroll down to the next one. Solve for W. So same steps, we're going to want to subtract 11 from both sides to get this W by itself. So we'll have a negative 76 W is greater than or equal to a positive 76. Dividing both sides by negative 76 to get W all by itself. Look, we're dividing by a negative once again. So that means our W is now going to be less than or equal to a negative 1. All right, moving on to 11, solving for a. We just have a few more steps than usual this time. We have a's on both sides of our inequality. So let's try to get our a terms on just one side. Since I like to have the variable on the left side, I tend to like to move it to the left, but that is just up to you. So plus 9a to both sides, because we have a negative 9a here. So that'll cancel it out. So this will be a negative 2a plus 20 is less than a negative 20. All right, and then let's get our constants just on one side. So we have a negative 2a is less than negative 40. And notice we don't flip our inequality sign when we subtract anything, because it's just when we multiply or divide by a negative. So just because we're subtracting here doesn't mean we change the sign. But once again, it looks like we're going to have to divide by a negative to get a all by itself. And let me just rewrite this up here so that we have some more room. So I'm just rewriting what we already had, not changing anything about it. So negative 2a is less than negative 40. Dividing by a negative 2, we're going to have now a is greater than a positive 20. So let's just get that. I'm going to scroll down so we can see 12 and 13. All right, some more multi-step equations. First step, we combine all like terms, and it looks like we have a negative 17 and a negative 9 on this side that we can combine. So that will end up being a negative 26. And then we bring down our minus 5z, and then we'll bring down the rest of the other side of this equation because it's already as simple as we can make it. So I've rewritten that, and now let us bring our z terms just to one side of the equation. So I'm going to add 3z to both sides to get negative 26 minus 2z less than or equal to a positive 2. I don't need to actually write that plus sign. Oop, just a 2. There we go. So now we're going to add 26 to both sides to get rid of it so that we can try to get our z as isolated as we can. And then continuing to write this problem all the way over here, we'll have a negative 2z less than or equal to, whoops, a 28. Right, dividing by negative 2. Once again, we're dividing by another negative, so we need to flip our inequality to be greater than or equal to negative 14. So there you go. Problem 12 is all done. So moving on to 13, solve for y in terms of w, x, and z. This is a different type of problem than before, whereas before we were getting an actual numerical value for our variable z, but this time our equation says y equals in terms of this. We don't have any numbers. That doesn't mean we make up any numbers. That just means we're going to rearrange this equation where instead of z equals, we have y equals. So I'm just going to just rewrite this over here. So z equals y plus w plus x. So looking at our steps from above, whenever we want to isolate a variable, which in our case we want to solve for y, we're going to have to subtract or add things away from it first. So right now it looks like we have a plus w and a plus x. So let's subtract this w from both sides. And now look, we're doing z minus w. We can't actually combine those because one is the variable z, the other one is a variable of w. So we just have to keep it separate. Z minus w is equal to y plus x. But once again, y is still not by itself. So we're just going to subtract x from both sides, and same as before, all three of these letters are different, so we can't actually kind of combine them. So we're just going to do z minus w minus x is equal to y. And then that right there is the answer. So it does say y equals though, but this right here, all we would have to do to get it into y equals form is just, you can just rewrite it, z minus w minus x, and then y equals over here. We don't have to change the sign of anything. All right, I'm going to scroll down here to 14 and 15. Number 14, solve for L in terms of A and W. So, again, we have A equals L times W. So I'll rewrite it here. And this is an L, not a T. But either way, we're solving for this variable right here. So whenever something is multiplying by something else and we want to get rid of it, we do the opposite, which in this case is divide. Divide by W. So we can get rid of those W's, and then we have A over W is equal to L, which is exactly what our answer is. And then that's it. All right, and then our last one that is like this, solve for U in terms of V and W. So V equals U minus W. We want to get U all by itself. So let us add W to both sides. We get V plus W equals U, which means our U is equal to V plus W. All right, let us scroll down to 16 and 17. All right, moving on to problem 16, we're solving for S. So I'm just going to rewrite it up here so we've got some more room to work with. Negative 13 minus 16s is equal to negative 15s minus 1. So we want to get s all by itself on one side. This time I'm just going to add it over to the right side, so plus 16s to both sides so that we can get rid of that. So you have negative 13 is equal to just an s, because negative 15 plus 16 is a 1. And remember, there's always a little invisible 1 in front of our variables, minus 1. And then we are going to add 1 to both sides. We'll end up getting negative 12 is equal to s, which that means s is equal to negative 12. All right, solving for C, it looks like we need to combine some more like terms here. On the left, we have a negative 20 and an 18C, so we don't have to do anything about that. But on the right, we have a 6C, a 14, and a 10C. So this 6C and that 10C need to combine together to be a 16C. And then you can drop down this 14. So I'm just going to cross that out there. We have a negative 20 plus 18C is equal to 16C. So now that we've combined our like terms, let us subtract 16C from both sides so that we can start to move things over. All right, so we have a negative 20 plus 2C is equal to 14. Let's add 20 to both sides. Nope, don't want to move that. There we go. Add 20 to both sides. And then move this up here. So we have a 2C is equal to a 34. So whenever you divide both sides by 2 to get rid of that 2 next to the C, we'll get C is equal to 17. There we go. All right, 17 is done. Now let's scroll down to 18. So it doesn't quite fully fit on the screen, but that is all right. Which one of these relations is a function? So how we know if something is a function just by looking at it is our vertical line test. So let's do our vertical line test. And the vertical line test is when we take a vertical line, which is up and down, and we just put it through any point we want on the graph. So like this, like that, and then let me scroll down so we can get the other two in frame here, that and that. So of all of these graphs, is there a point that intersects more than once? So let's see, in this first one, I see it intersects right there, right? And this one, it intersects here, here, and here. So we have 3 points that it touches. And then this one on the bottom left intersects twice, and same with this one here on the bottom right. So if it passes the vertical line test, that means that the vertical line that you just drew will only hit the graph once at any point. So yeah, I know you can draw a line over here and it only crosses once, but since we can see over on the left side of this graph that it will cross it more than once, that fails the vertical line test. So same with the bottom left and the bottom right, because it intersects twice. But this option over here on the top left, when you put a vertical line through it, it only touches it once, which means it passes the vertical line test. So that means that this option right here is the correct one for number 18. So now number 19, I guess just take a second and see which one of these will pass the vertical line test. All right, so let's test it. This one right here, no, it touches it more than once. This one, I know it's not fully on the screen, but even the part that we can see touches more than once. This one here, looking at it, I mean, yeah, it looks like it passes. This one here, it does not. So that means our answer is the bottom left. All right. All right, now we are moving back over to solving for some things. Use the following function rule to find f of 9. F of 9 is basically saying what is the value of y when x is equal to 9. That's the very long version of what f of 9 stands for. So if x is equal to 9, and we have an x right here, that means we are just going to plug our little 9 into that x. So this is saying that f of 9 is equal to 9 minus 1 squared. And don't forget to do inside of your parentheses first. So let's bring that down. 9 minus 1 is just 8 squared, which happens to be 64. So f of 9 is equal to 64. And now be careful not to mistake this f of 9 for f times 9, because that is not what this is. So just careful not to start moving this left side of the equation into the right one, which is why you see me, I set it up properly here, but then I didn't even look at this side of the equation as I solved down to get 64. All right, and then 21, use the following function rule to find f of negative 37. So once again, this negative 37 is telling us that the value of x right there should be negative 37. So I'm going to write it over here. So f of x, which actually is now, let me erase that, f of negative 37 is equal to 4 minus, and then up top we have an x, but our x is negative 37. So I'm just going to put negative 37 divided by positive 37. So bringing that down, we have 4 minus negative 37 divided by 37 is a negative 1. and we have two negatives here. So this is the same thing as saying 4 plus 1, which would mean that our answer is 5. So f of negative 37 is 5. So let me scroll down and let's solve an inverse function. So this is something that we haven't done in a while, and I will write down all the steps here. So first I'm just going to rewrite our equation. So of course, as always, we have more room for it. And then on the midterm, I will make sure that you have a lot more room than this to write your problems down, so that everything isn't all squished together. So I just rewrote f of x is equal to x plus 4. What an inverse function is the first step is, instead of saying f of x, we're just going to say y equals x plus 4. Okay. And then our next step is you're going to switch x and y. So instead of saying y equals x plus 4, we are now going to say x equals y plus 4. Okay. And then solve for y. So in order for us to solve for y, let us get y alone by doing minus 4 to both sides. All right, so we have x is equal to, more of like x minus 4 is equal to y. And then let me just rearrange that a little bit so that we get y is equal to x minus 4. So now that we've solved for y, you're going to replace y with the notation of f inverse of x. So replace y with that. So let me just scroll down a little bit more. So instead of y, we're going to write f inverse of x is equal to x minus 4. And then that right there is the answer. So once again, you just rewrite it. Instead of saying f of x, you write y equals, and then your equation, you just switch the letters x and y, and then solve for y. And then finally, the last step is to then replace y with f inverse x equals whatever you solve for. All right. So what is the range of this function? So range is our y values, right? Y values. So that means we're just going to be looking at what I have highlighted here. We're just going to be looking at those values. We're going to ignore the x values here because we don't care about that at this moment because it's just asking us what is the range. So we don't want to accidentally get mixed up. So range, we always want to list range or domain, either one, from least to greatest. So our values from least to greatest, let's look. It looks like the smallest value of y that our graph is right here. And this value, if we kind of look over here, it's between -2 and -4, which makes me think that that is a -3. So our least value is -3. And then let's take a look at our most value. So it looks like our graph just goes up to 10, but then we have little arrows here. So I'll just emphasize those arrows. We've got little arrows on our graph. And that is telling us that this line keeps going on. Like, no matter how large we draw this graph, that line is just going to keep going on and on and on and on forever. So our greatest value of y is actually just like infinity, basically. So if y, the lowest value of y is -3, and the greatest value just keeps going on and on, that is saying to us that y has to be larger than -3. But there's two different signs that we have. We have greater than, and we have greater than or equal to. And how we know which one is which is that greater than or equal to is our filled in circle, and greater than is an open circle. But looking at our graph, we don't have any circle at all. We just have a solid line. So a solid line is also the same as a filled in circle. Therefore, we're going to use y is greater than or equal to -3. And that will be our answer there. Which, scrolling down, should be option number 2. Y is greater than or equal to -3. And then this little y in the line here is just saying that our y values are. We're talking about range, so that's just the notation that they're using. All right, scrolling down to 24, we have yet another domain and range question. And this time it is giving us not really a table, but just a set of points. It kind of looks like a table though. So last time we figured out our range values are the y values, which means the domain have to be what's left, which is our x values. And then I'll write range again down here, y values. Or they represent them. So looking at our x values, that's all of these points on the left, and our y is all these points on the right. So everything, again, needs to be ordered from least to greatest. And we also don't repeat our values. So you see over here, we have a -9 and we have another -9. When we list domain out, you don't list -9 twice. So let's see our values for domain. So I'm just going to write it as the letter D. So we have a -9, and I'm going to try to write it from least to greatest. -9, -2, -1, and then we already have that -9 and a 0. So it looks like those 4 are our domain values. So looking at our 4 options here, it looks like this, they're saying there's like a 1 in the domain. That's not our domain. That, maybe they were looking at the y values, but that's not it. So it can't be these bottom 2, because this one on the right also has a 1, which means that just knocks out these entirely from our options. So it can't be either one of those, and it looks like it does match these top 2, so that means all that's left to do is to look at our range. So you have a 1, -1, -6, 8, and 2. Those are not in order. So let's write them in order of least to greatest. So least looks like it'll be a -6. And then above that is our -1, +1, R2, and then R8. So we have -6, -1, 0, 2, and 8. We don't have a 0 in our range. So that's not it. And this one's -6, -1, +1, 2, and 8, which matches, and our domain, as we found before, also matches, so that means this box right here is our answer. And then let me just scroll down to 25 really quickly. 25, we are not going to have a question like number 25 on our midterm exam. 25 will be replaced with another one similar to 23 and 24. We're just going to be asked the domain and range either from a table or a graph, but it will definitely be something that we have seen before. Question number 25 just has an assumption that we know what this graph looks like, and we haven't really covered that. So 25 will not be on our midterm. All right, so I don't want anyone to think that it will be, but I will just show the answer just in case anyone had remembered what this type of graph looked like or just wanted to know. This domain would end up being all real numbers, but again, this will be covering later in the year and not right now. So, all right, that is all the answers to part A of our midterm review, and I will also go ahead and do part B of our midterm review, but in a separate video. All right, hope this helped you guys. Good luck studying.